Hello there, this is Mr. Samuel from TSAM's Training, and today we will be looking at the structure of VHDL code, and in the later videos we will be looking at some examples. This compiler, this software can actually be downloaded free of charge from the Xilinx website. This compiler is called the ISA Project Navigator, and it's part of the ISA web pack. There are other vendors out there as well, including the Altera, but I just prefer this compiler. I think it's quite easy to use and it has so many functionality. So, but it's down to you actually. So you can either choose to download the software or choose the other, uh, choose from other vendors out there. So now we will be looking straight into the VHDL code. So looking at the code here, you can actually see that there are four major. This code is actually divided into four major sections. We've got the entity here. We have the architecture. We have the process, which is within the architecture, and also we have the declaration at the top, which is the library IEE, and also another declaration here telling us the type of logic that we're going to be looking at, the package, which is called a standard logic 1164. So now let's look at the concept of design entity. The design entity in VHDL language describes a hierarchical hardware design. The word design entity in VHDL is a technical term, and that just describes the hardware function or the block of hardware which is made up of logic gates. So in this our design entity, we have four different logic gates. We have the NAND logic gate, the XOR logic gate, the AND, and the NOR logic gates. So now we now need to look at the concept of entity and architecture. Okay, so at the moment we've got our entity, no name, and also our architecture, no name. So we have to actually declare what those things are. Okay, so the entity itself describes the interface, the inputs, and the outputs. So for in our design entity here, we've got A, B, C, D, E, F as our inputs, and our output as Q. Okay, so we're just going to go ahead and declare those. So, and that's it. So now our entity, we're going to give our entity a name, and the name comes from the actual logic gates. N for the NAND, X for the XOR, A for the hand, and then the N for the NOR. So entity NXAN gates, and then we declare our ports, the inputs and the outputs as our ports. And for the inputs, we have A, B, C, D, and F, and their inputs. And for the type, we're just going to focus on standard logic. So our type here is just standard logic, which means our input can only be either 1 or 0. And then our output as well is a Q, and the output also can only be 1 or 0. So that's the type, standard logic. And then we're going to end it and entity. So that's entity completed. And including the name at the end is optional. So you can either add it, or leave it out. Okay. So now we now want to move on to the architecture. We want to declare our architecture now. Okay, so what we want to do now is to add our second architecture. And the reason why we want to do that is I've looked into the same circuit that we have before and added some signals to it. Okay, and we want our second architecture to be able to use these signals. Okay, so I'm going to go back here, and the fact here is that VHDL supports the concept of multiple architectures. This means a single entity can have two or more architecture implementation. So we now have to use, so now we're going to use J2 for our second architecture. Okay, so I'm going to type the code in here. Alright, so that is our second architecture. So starting from here. Okay, good. Alright, so the internal connections or signals are used inside the architecture, so they must be declared. So all the signals that are used inside the architecture must be declared, and this must be declared before the word begin. So here we have the signal. So I have the signal A, B, K, X, C, X, D, E, F, O. They're all declared, and each signal that has the same type can actually be grouped together. Okay, and then after the keyword begin, we now have our concurrent assignments. The order in which the assignments are written has no effect on their behavior. So each signal assignment will be synthesized to the equivalent combination of logic gates as shown in the diagram. Okay, so from where we are now, all we have to do now is to add some stimulus to our code and then synthesize it.